Hello to everyone. In this video, let us discuss second order reactions and third order reactions. So first, let us see second order reactions. So the reactions in which rate is determined by the variation of two concentration terms, known as which one? Second order reaction, or the reactions in which rate is determined by or depends on two concentration terms is known as second order reaction. So now what are the examples for second order reaction? The first one is ester hydrolysis in alkali medium. This is most important. In acidic medium means that is an example of which one? First order reaction. But ester hydrolysis in alkali medium is an example of second order reaction. And second example is here conversion of ozone into which one? Oxygen, and decomposition of NO2 into NO and oxygen. So these are some examples of which one? Second order kinetics or second order reactions. Okay, then after that, how to determine, or what is that rate constant expression? What is rate constant expression? Let us see here. As it is given second order means we can write 2A gives products. Initial concentration A and 0. But at T time, X moles of products are formed, means from here A minus of X. So therefore, K equals to, or we can write simply first, rate equals to K into A minus of X whole square. Upon solving, we can get K equals to 1 by T x by A into A minus of X. So this is the rate constant expression when 2A gives product, such type of reaction is given. But sometimes A plus B gives products. Like this also the second order reaction might be there. Initial concentration A and B 0 and X moles of products are formed means A minus of X and B minus of X. These are the concentrations of A and B after T time. Therefore, for this type of second order reactions, rate equals to K into A minus X into B minus X. And upon solving that, we can get K equals to, what we can get here? 2.303 by T into A minus B log B into A minus of X by A into B minus of X. So this is the rate constant expression for second order reaction in which two different reactants are participated. So these are the rate constant expressions for which one? Second order reaction. And then let us see the characteristics of second order reactions. So first let us see the units of rate constant K. What are the units of rate constant? We know the formula: mole to the power 1 minus n, liter to the power n minus 1 second inverse. These are the units of which one? K. As it is a second order reaction, substitute n2, n value 2 here. Therefore, what we can get? Liter mole to the power minus 1 second to the power minus 1. So these are the units of rate constant for second order reaction, and therefore half-life time equation is what we can get? 1 by K into A power 1. That means here for second order reaction, half-life time is inversely proportional to the initial concentration. So this is regarding which one here? Second order kinetics. And then we can go for which one here? Third order kinetics. So then after the second order kinetics, let us see the third order kinetics. Third order reactions means what here? The reactions in which rate determined by the variation of three concentration terms, or the reactions in which rate depends on three concentration terms known as third order reactions. So now here we can write some examples for third order reaction here. What are the examples here? 2NO 2NO plus or 2NO plus O2. What we can get here? 2NO2. So this is one example for which one here? That third order reaction. 2 and 1 here. The rate determined by the variation of these three concentration terms. So this come under which one here? That third order. Or we can write 2NO plus Cl2 gives 2NOCl. This is also an example of which one? Third order reactions. Okay, then for such type of third order reactions, what is that rate constant expression? Okay, let us see rate constant expression. K equals to 1 by T into, here we can write x into 2a minus of x by 2a square into a minus of x whole square. So this is the rate constant expression for which one means that third order kinetics. And half life time T of equals to what we can write here? 1 by k into a power 2. That means half-life time is inversely proportional to the A square. That means initial concentration is which one? A. So this is regarding which one? Third order reactions. Okay, now some reactions also there, those are called pseudo first order reactions. Pseudo first order reactions means what? Molecularity is 2 but order is 1. Such type of reactions are known as pseudo first order reactions. Example, ester hydrolysis in which one? Acidic medium. Ester hydrolysis in acidic medium is first order reaction, but molecularity of that reaction is 2 because both ester and water participating in that rate determining step. So molecularity of that reaction is 2 but order is 1. So such type of reactions are called pseudo first order reactions. So now after that we have to see the graphs related to first order, zero order, second order kinetics, etc. So first for zero order kinetics, now x versus time. So we can get a straight line parallel to which one? Time axis. And if you come to first order reactions means here what we have to consider? Log a by a minus of x versus time. So now we can get a straight line with a positive slope. And then for second order reactions, what we can get here? X by a into a minus of x versus time. We can get again a straight line passing through the origin having positive slope. And otherwise for the same second order reactions we can consider another graph, log b into a minus of x by a into b minus of x versus time. Again we can get a straight line with positive slope passing through the origin. So these are the different orders and that graphs related to which one? X and time, log a by a minus of x versus time, etc. And then let us see the graphs related to which one here? Half-life period and initial concentration. Okay, now for such type of graphs we have to consider here which one? Half-life period and initial concentration. Now for zero order reaction, that is directly proportional, so we can get the line with a positive slope. And for first order reactions, half-life time is independent on initial concentration. So we get a straight line parallel to this initial concentration axis. And for second order reactions, now half-life time is inversely proportional to initial concentration. So let us consider 1 by A. Then again you can get a positive slope. Of course, if initial concentration A is taken, means this line with the negative slope we can get. But what we have taken here 1 by A. So positive slope. So like that, these are the graphs related to which one here? Half-life time and initial concentration. Okay. After this, the last topic in this which one here? Determination of order and also collision theory of reaction rates. Okay, first we have to see which one? Determination of order. Okay, so many methods are there, but in that one important method, half time method. So what is half time method? We know that T of proportional to 1 by A to the power n minus 1. So now T dash half by T double dash half equals to what we can write now? A double dash by A dash to the power n minus 1. That means by using initial concentrations and their half-life periods, one can determine n. What is n? Nothing but order. So this is one of the methods to determine which one order. So this is important method. Okay, then after that let us see which one here? Collision theory of reaction rates. So what is that collision theory of reaction rates? Let us see here. So first, reactants shall have to collide to give the products. Reactants shall have to collide to give the products. But all collisions do not lead to the products. All collisions do not lead to the products. The reactant molecules which have minimum amount of energy, only they can give the which one? Products. The minimum amount of energy required to give the products is known as threshold energy. But reactant molecules may not have that which one? Threshold energy. Now the difference between threshold energy and reactants molecules energy is known as activation energy. Threshold energy minus reactant molecules energy difference is known as activation energy. So we can represent with one graph here. Let it be the reaction path and this is energy axis. Now these are the reactants. The reactant shall have to possess a minimum amount of energy to give the products. This minimum amount of energy is called threshold energy, and this is reactants energy. This gap is known as activation energy. This is the activation energy of a forward reaction, and this gap is the activation energy of a backward reaction. So like that, this is activation energy of forward reaction, this is activation energy of a backward reaction. So like that, here the difference between threshold energy and reactant molecules energy is known as activation energy. Then reactants when collide with each other, some molecules loses energy, some molecules gains the energy. The molecules which gain energy, they are called activated, which can gain activation energy, they are called activated molecules. Now the collisions among activated molecules will give the products. These collisions are called fruitful collisions. These collisions are called which one? fruitful collisions. So this is regarding which one? Collision theory of reaction rates. Okay, then in this let us go for which one here? Some important questions based on that energy diagram. Here based on the diagram some questions we may get here. So what are the different type of questions? Let us see here. See, this is which one? Reactants energy, this is the product energy, and this is a threshold energy. The gap between threshold energy and reactant molecules energy is known as activation energy of a forward reaction, and this gap is known as activation energy of a backward reaction. So now what are the questions we can get from this? And another one here, this gap is known as delta H. Energy of products and energy of reactants gap is known as which one? Delta H. So the first question here, first one, what is here? Activation energy of forward reaction is 40 joule and activation energy of backward reaction is 60 joule. Now the question is, what is the delta H for forward reaction? What is the delta H value for forward reaction? For such type of questions, first let us draw the diagram. So see here, activation energy of forward reaction 40 joules. Let it be the gap between reactants energy and threshold energy. This is 40. Let us consider 40. And we have to draw this side also one line. But while drawing the line, we have to observe that whether this gap means what is this? Activation energy of backward reaction. In the given question, which is having greater value, let us see here. Activation energy of backward reaction 60 joules, activation energy of forward reaction 40 joules. That means which line should be in lengthier size activation energy of backward, because this value is 60 but this value is 40. That means we have to draw this line somewhat lengthier than this line, and then here we have to write that gap. This gap is how much? 60 joules. That is backward reaction activation energy, and forward reaction activation energy 40 joules. Write this, and we have to determine delta H for forward reaction. That means we need to determine this gap. So now from here to here 60 joules, from here to here 40 joules. Therefore, how much energy here we left over means 20 joules. So delta H equals to 20 joules. But whether it is plus 20 joules or minus 20 joules, that is also important now. See here, this is the reactants energy, this is the product energy. From bottom to top, as we are moving, energy value increases. That means products having less energy than reactants. So if product energy less than that of reactants means that is exothermic reaction. Therefore, what is now delta H sign means minus 20 joules. Let us see another such type of question here. What is that? I give another question. Activation energy of forward reaction. Activation energy of forward reaction 70 joules. Activation energy of backward reaction 40 joules. Now, what is delta H value for which one? Forward reaction only they have given. First, let us draw the which one graph for that reaction path and that energy. So now, first consider this. Which one? Activation energy of forward reaction 70 joules. Of course, this height is 70, but this height only 40 joules. That means in this side we have to draw a short line comparatively with this, because this length they have given 40, but this length they have given 70 joules. So now here this gap is how much means 70, this gap is how much means 40. We have to determine this gap. This gap is how much means 70 and 40. What is the difference? 30. So delta H equals to 30 joules. But is it plus 30 or minus 30? Very easy. See here, reactants energy here at the bottom line, products energy at somewhat top. That means products energy more than that of reactants. If product energy greater than that of reactants, then that should be which one? Forward reaction should be endothermic. So therefore delta H for forward reaction is plus 30 joules. If what is delta H for backward reaction means what happens? Value is the same, but invert to that. That means exothermic in nature, means we can get delta H minus 30 joules. So these are the questions related to which one? That collision theory of reaction rate and that related to that graph. Okay. Bye.